This week's lecture is on over 2.2 applications of Venn diagrams. So we are going to use Venn diagrams to analyze the results of a survey, and then develop and apply De Morgan's laws of complement. So when I talk about complements, I can do there's a long way to go about it and a short way to go about it. And the short way is using De Morgan's laws. So Venn diagrams are a very useful tool in visualizing the relationship between sets. So up until this point, we've done things with Venn diagrams, but they haven't really panned out to be extremely useful. In this section, you won't be able to do the problems without drawing a picture of a Venn diagram. So they can be used to establish general formulas involving set operations and determine the cardinal numbers of sets. They're very useful in survey analysis, and that's majority of the time what you'll use them for is being able to do survey analysis. So let's look at this example that's on your PowerPoint. So a professor in his film class conducted a survey of people watching a movie, and they were given a slip of paper. It says, I watched a movie in a theater during the past month, or I watched a movie on DVD the past month. So it's possibly, that you could have done both. Watched a movie in theater and on DVD. So after he collected the forms and tabulated the results, he told the class that 388 people checked the theater box, 495 people checked the DVD box, 281 people checked both boxes, and 98 of the forms were blank. So only given this information, the professor asked what percent of the people surveyed watched a movie in the theater or on DVD the past month. So really, to answer this question, it would be best to get a Venn diagram. So we only have two things going on here. People watching movies in theaters. So let's put this as the theater. People watching movie on DVD, and it's potential that they can overlap. So I know everything inside, and this is the universe. Everything inside the theater box has to be 388 because 388 people. Now some of those people also watched it on DVD, so they're going to be in the middle. So the 281 people did both. So that means they watched the movie in theater and on DVD, so they go here. And then on DVD, 495 people had checked the DVD box. Now, if I want to know how many people just watched a DVD and not in the theater, I'm going to use a calculator to say 495 minus the people that checked both boxes, 281, that tells me I have 214. So 214 people only watched a DVD. 281 people watched a DVD and a movie in the theater. So if you take 281 plus 214, you get 495. And that's the total number of people that watched a DVD. I can do the same thing with theater. People that watched a movie on theater, I have 388 minus 281, and that's 107. So that tells me 107 people watched a movie in theaters. And then we also know that 98 of them were blank. So in the universe, 98 people did not watch a movie in theaters or on DVD. So if I want to know what percent of people watched a movie in theaters or on DVD, I'm going to take 107. Those are the people that watched it just in theaters, plus 281. Those are the people that watched a movie in the theater and a movie on DVD, plus the people that just watched a movie on DVD, divided by the total number of people surveyed. So the number of people surveyed in the universe, I'm going to sum up everything in my boxes. So that's going to be the universe. The number of people surveyed in the universe would be 98 plus 388 plus 214 plus 281 plus 107. So if I pull up my calculator, I have 98 plus 388 plus 214 plus, oops, I did something wrong. 98 plus 3, oh, sorry, that's my error here. This 388 would be 107 plus 281. So let me fix this here. That I would add up 107, 281, 214, and 98. I do not add what I have in red because what I have in red is going to be the sum of this circle, which would be 107 plus 281. And then over here, what I have in green is going to be the sum of the DVD circle. So this would not be correct. The number of people in the universe would be 107 plus 98 plus 281 plus 214. Now if I pull up my calculator, I have 107 plus 98 plus 281 plus 214. Now I get 700. So 700 people surveyed. So if I take I take 107 plus 281 plus 214, that's 602. So here I have equals 602 divided by 700. So if I take 602 divided by 700, that gives me 0.86. So if I want it in a percentage, I take that times 100 to get a percent, and I get 86%. What percent of the people surveyed watched a movie only in theaters? So I only want the circle, I only want the number of people in only the T circle, not the T and D circle, just the T circle. So that's going to be 107 over 700. So if I do my calculator, 107 divided by 700, it's going to give me 0.1528. So I have 0.1528, which is approximately 15.3%. Be careful the way WebAssign asks you to input it. If they want it in a percent, you need to give it to them in a percent. And then if they want so many decimals, you'd have to use so many decimals. What percent of people surveyed watched a movie on DVD only? So now I'm looking for the percent that only watched it on DVD, which would be 214. So I'd have 214 divided by 700. So then I go back and I do 214 divided by 700. So that would be 35.6. So I get, I think it was 0.3057. 0.3057, so that's approximately 30.6%. So you can see I wasn't given the number of people that only watched it on DVD, but I could extrapolate that. I could figure that out by drawing this Venn diagram. With 3 sets, it gets a little bit more complicated. You have an A, a B, and a C. So you would have an overlapping of A and C, and an overlapping of A, B, and C. So 1, 2, 3, 4, 5, 6, 7, 8. 8 possible regions here. But with 2 sets, we only have 4. 1, 2, 3, and 4. So it gets a little bit more complicated with more. I'm only going to give you 2 sets on your homework. So So let's try to figure out some things about complements, and remember complements are things not in the set. So for the given set, would I say A union B complement is A complement union B complement, or would it end up being this one? So I can test myself by an example. So let's figure out this example. Well, let's look what A union B complement, what that set would look like. So let's not test this side yet. Let's figure out what the left-hand side would be. So what is going to be A union B complement? Well, what is A union B? A union B are the number of elements in A and the number of elements, or not the number, the elements in A and the elements that are in B. So A has 1, 2, 3, and B has 2, 3, and 4. So this would be the elements in A union B. So if I want to find the complement of that, I would take the complement in that set. So that's going to be the elements in the universe that aren't in A union B. So that would just be 5. So that would be 5. So A union B complement is 5. So I know that this is just going to be the set of the element 5. And this is just the set of the element 5 because it's the same thing. Now I'm testing which right-hand side is going to give me the set of only including the element 5. So let's go here and look at this. What is A complement? A complement is everything not in A, which would be 4, 5. B complement would be everything not in B. So that's 1 and 5. So now if I do A complement union B complement, that's everything in A not and then everything in B. So that's 1, 4, and 5. That does not equal 5. Does not equal 5. So automatically I know this one's not going to work. So let's test to see if this works. So A complement's given and B complement's given. So I don't have to calculate that again. But what would be A complement intersection B complement? That's going to be the elements that are in both A and B at the same time, which would be 5. Only element 5 is in A and B. That is the same thing as the left-hand side. Yes. So that tells me if I want to do complements of like A union B complement, then I'm going to take A complement intersection B complement. And this is known as De Morgan's law. So you can memorize De Morgan's law and learn how to apply them, or you can always just do A union B like we did here. We did A union B. We did what's in parentheses, and then we took the complement of what's in parentheses. We got the same answer. So for any set A and B, A union B quantity prime, so if I'm taking the union of two sets, if I want the complement of that set, I take the complements of the set, but I take the intersection of the two sets. So that is, the complement of a union is the intersection of the complements. And then also, if I'm taking the complement of an intersection, that's the union of the complements. So let's look at an example using De Morgan's law to find A complement union B quantity complement. So I could go about the long way, find A complement, union B, and then find the complement of that set. Or I can apply De Morgan's law. And it doesn't matter which way you do it, but let's apply De Morgan's law here. So if I have A complement union B quantity complement, that's going to be the same thing as taking A intersection B complement. So A is given as this. So I might want to write B complement. B complement would be everything in the universe that's not in B. So not 0, but 1, 2, 3, not 4, not 5, but 6. not 7, not 8, and not 9. So that would be the set B complement. And then we're looking for the intersection. The intersection. So what elements do they have in common? They have a 2 in common. They have a 3 in common. And that's all. So my answer would be A complement union B prime would be the set of elements 2, 3. So you can convince yourself of it the longer way by taking A complement union B and then taking the complement of that, which would just be 2 and 3. So let's look at some examples from the homework. A local 4-H club surveys its members, and the following information was obtained. 14 members had rabbits, 7 had goats, and 5 had both rabbits and goats. 18 had neither. So this is the same format as the example we did of DVDs, watching a movie on DVD and watching a movie in the theater. So you're going to start with drawing a picture of the universe. We have the people that have goats, the people that have rabbits. So this would be the goat people, the people that have goats, and the people that have rabbits. So 18 people did not have goats and did not have a rabbit. 5 people had goats and a rabbit, had both. 7 had goats. So if 7 people have goats and 5 have goats and rabbit, then that tells you 2 people just have goats, because together 5 plus 2 is 7, and that would be the 7 with goats. 14 had rabbits, so that would tell you 9 just have rabbits, because you know 5 have rabbits and goats. So now we're wanting percentage, and it's saying round your answer to 3 decimal places. So if I go about this here, I need to find out how many total people were surveyed. How many people are in the universe? So the number of people in the universe is going to be 5 plus 2 plus 9 plus 18. So 5 plus 2 plus 9 plus 18. And that tells me 34. So I had 34 people were surveyed. So now, what percentage of the members had rabbits or goats? Well, that would be 2 plus 5 plus 9 over 34. So 2 plus 5 plus 9 is 16 divided by 34. So this would be 0.47. So I get this from my calculator. I get 0.47 0.58 0.58. So now I need to write it in a percent, so I move the decimal 2 places. So that tells me I have 47.05, and it wants you to round your answer 3 decimal places. So 1, 2, 3. I look at this one, it's bigger than 5, so that makes that a 9. So 47.059% of the people surveyed had a rabbit or a goat. So the next example, how many people had just rabbits? Well, that would just be 9. So this would be 9 divided by 34. Plugging that in my calculator. I have 9 divided by 34, and that gives me 2647058. So what I get from my calculator, 0.2647058. I want it in a percent, so I move 2 decimal places over. It tells me 26.47. So I need 3 decimals. I look at this one, it's a 5, so I round this one up to a 1. Only had goats. You're going to tab 2 out of 34. So calculator, and you go through the same process. The next example we're going to look at is use the data in the table below to complete the exercise and round your answer to 0.1%. So that's 1 decimal. Out of all the people who have O blood, all we care about are the people that have O blood. What percent have an Rh positive factor? Well, how many total people that have O blood, if I come over here, that would be 38 plus 7, that would give me 45. So 45 is my bottom number. Rh positive would be 38 out of 45. Rh negative would be 7 out of 45. So now if I take 38 divided by 45, that gives me 84.4. So 84.444. So that is, if I want it in a percent, 84.4%. Seven divided by 45 would be 15.5%. So seeing what I got from my calculator, it looks like this. So that's approximately 15.5%, but I need to round because it says round off your answer to 0.1%. Since 5 is larger, since 5 is 5 or larger, I'm going to put 15.6. Majority of the time, students that make an error on this type of problem is a rounding error, so be careful with that. So this is 84.4, and the percent's already there, so you don't put it there. And then 15.6, and the percent's there. So good luck with this section. The nice thing about this section is the problems take some time. So on 2.2, if we look at, let's see if I go to student view of this. Wouldn't want you to see all the answers. 2.2. You only have 7 problems. So that being said, be careful because the red numbers are going to change. So these red numbers are going to change. If you get stumped, you can do the watch it. And the watch it will give you a problem like this and it will show you how to work through it. So part A. But the numbers are different. So be careful that you can't use their numbers. But I don't think I have my speakers on. So he's explaining it to you, and then he'll draw a picture, and he can show you what's going on. So keep in mind, though, your numbers will be different. Once you try it, if you try it again, these numbers will change. Any numbers in red are going to change. So be careful with that. Microwave and DVD player, the same concept of what we did on the PowerPoint. We did this example on this video, so we did this example on the video. And then here you can use De Morgan's laws, or you can go about it the long way. It says use De Morgan's law, but they can't necessarily see your work. So generally, you'll find one way is faster using De Morgan's law, and I'll let you guys figure that out. So this is the end of 2.2. If you have any questions, let me know.